which is net force, mass times acceleration. If you read the uh, handout or the lab carefully, we're going to derive two equations to calculate the net force. So the first one is m2 times g. m2 is different masses we hanging on the end of that string, and we vary the hanging mass 50, 70, 90 all the way to 230 grams. So this column you need to convert these grams uh, into kilograms by dividing 1,000. So I'm going to show you only one row. I will choose I'm going to complete the last row in this table. So if I convert grams to kilograms, you will get 0.23. M1 is mass of the cart, which is same for every value for different values of M2. So therefore, M1 is 0.51. M1 plus M2 is 0.74. Okay, so M2 times G, M2 is 0.23, M2 times G is 0.23 times 9.8 meters per second square, which is equal to 2.25 kilograms meters per second square, which is Newton. So 2.25 Newton. And this is one way to calculate the Newton's law or the net force. And the second way is M1 plus M2. A is the acceleration we measured and which is listed in this column. So M1 plus M2 is here plus A times A, which is equal to M1 plus M1 we just calculate 0.74 times A is 3 meters per second square. So if you do that calculation, you will get 2.22, which is Newton. So 2.22. So you see a slight difference between the values you calculate from one way and the second way. So you can get the error using the formula given in. So you can complete the table, rest of the table just like this, and answer to these questions at the end of the lab, and that will show, you know, the Newton's law force is consistent with the mass times acceleration. So which proves Newton law, second law, is valid for our net force equals mass time acceleration.